everyone, this is Dr. Matsuko with our introductory video lecture on cosmology. We're going to cover the modern viewpoint of the majority of physicists and scientists on where the universe came from and how it was made, and also talk about what are the outstanding problems and issues regarding it. But before, there we go. But before I get into talking about modern scientists, I want to share my own personal view, which is that God created everything in the entire universe. God created the entire universe itself, right? By universe, I mean the totality of all matter, energy, and space, of everything. The ancient Hebrews actually used the term the heavens and the earth to mean everything. Hashemayim v'haaretz, right? And this is in Genesis 1:1, right? So in the beginning, God created the heavens and the earth. I actually like to think about that. My own translation of it is, in the beginning, God created the universe. God created everything. So the Bible is very clear, starting from the very first verse, that everything comes from God. Everything is created by God. The New Testament also confirms this, right? If we look at John 1, right? In the beginning was the Word. The Word is Jesus Christ. The Word was with God. The Word was God. He was in the beginning with God, and all things were made through him. Without him was not anything made that was made. Right? So all things, the entire universe was made through Jesus Christ. So throughout the Bible, this holds true that if you believe in the Bible, then you believe that God created everything in the entire universe. And as we've discussed earlier in the semester, elsewhere in the semester, there are different interpretations of the Bible, how exactly God created everything. But without a doubt, God did create everything. And so in this lecture, I want to talk about the modern physicists' explanation for how God created the universe, the actual process of how the universe was created. Okay. And it all mostly starts with this guy, Edwin Hubble. And so he himself is a very interesting character. He graduated from the University of Chicago. He actually was like their lead basketball player, and they went on to win a championship. I don't remember if it was national or regional or something, but he was actually a great basketball player. He was very tall, but he was also an incredible scientist. He after his undergrad, he went on to do a PhD, and actually while he was doing his PhD, World War I broke out, and he rushed to finish his PhD so that he could join the U.S. Army in World War I. But actually, he did join the Army, but actually the war ended before he was deployed. But he was very passionate, and he was a very strong leader. Right. So, and he ended up studying, or not studying, he ended up working at the most prestigious telescope observatory at that time, which is the Mount Wilson Observatory. Right. It was, I forget exactly where it was, out in near California, or in California, but in a desert area where there's basically no people and no light, and so they could like see the stars, and they had this huge telescope, right? We have my pen is working, right? A huge telescope that they could see the night sky more clearly than anyone has ever seen it before. And so actually in the early 20s, he was looking at these nebulae, what people call nebulae, which basically are like clouds. They were just like, I don't know why there are clouds next to all these stars. And it turned out if you looked more carefully at these clouds were actually a whole bunch of stars. If you could see it in higher resolution, you actually saw it was a whole bunch of stars. And so they themselves are actually galaxies of stars. So before this, everyone thought there was just the Milky Way galaxy. There's just one galaxy. And Hubble discovered that there are actually other galaxies outside of our own, and he actually pushed forward and published his work in the New York Times even before his peers approved it and agreed with him, which goes to show what a confident, almost arrogant, you could say arrogant, scientist that he wasn't going to wait for peer review. He was so confident in his work. But thankfully, it was information, not misinformation, as we have too much of these days. He ended up being right after a while. After several years, he has been confirmed by his peers, but he moved forward very quickly. And so that was his first kind of claim to fame. His second claim to fame, which is what he's more famous now, is Hubble's Law. So that came out in 1929, and he did publish this first. I think by this time he was himself prestigious enough and popular enough among scientists that he was able to rush his scientific papers. All right, so what is Hubble's Law? So Edwin Hubble looked at the distance of galaxies far from us, and then he looked at their spectrum shifts. So according to the Doppler effect, which was from 1700s or something, anyways, the Doppler effect was well known at this time. Is basically if there's a blue shift in the spectrum of a galaxy or a star, that means the star or the galaxy is moving towards us. Right? Blue means towards us, and a red shift means away from us. And so there's a lot of great videos on the canvas. In the link, I put a link to a video that explains the Doppler shift. But what you need to know is that by looking at the spectra, by looking at the colors of these stars, or a certain aspect called the fingerprint of the colors of the stars, you can tell if it's moving away from us or moving towards us. And so Hubble noticed that all of the galaxies that were far away were exhibiting redshifts. And the further away the galaxy, the larger the redshift. And so if we graph this, right, we can have their distance of the galaxy from us and the velocity, which is calculated from the redshift. Basically, any galaxy that was far from us was exhibiting a redshift, so it's moving away, or commonly called, or popularly called receding. Right, you had the receding or the recessional velocity, and so the further away it was, actually the faster it was going, and it made a very nice line here, which is awesome. Scientists love it when there's nice lines, and so obviously there's a direct correlation going on, and so we try to explain and figure out what that direct correlation was. And so the explanation that Hubble chose, that he adopted, and which we still agree with, is that basically the universe itself is expanding. Right? So if we are a certain, I love this picture of this bread that has all these raisins in it, and the bread is rising, and so the bread itself is expanding. And if we are just one little raisin, right, and then as the bread itself is expanding, then all the raisins that are far away from us will get further away from us. But the ones that are furthest away will have to go even further. Right, so if all of them double in their distance, that means the ones that are further away are moving faster. Then they've gone a further distance over the same amount of time. Right, and so the space itself is expanding. That's the consequence of Hubble's law. And so this comes from just looking at all the stars, looking at their spectrum shifts, and determining, wow, so the whole universe is actually moving. It's expanding. It's changing. Another interesting character that's part of this is George Lemaitre. So while Edwin Hubble gets the credit for Hubble's law, actually there is a movement to update the name to Hubble-Lemaitre law, but the name Hubble's law has just stuck. Actually, this law, or this theory, was discovered 2 years earlier by George Lemaitre. Unfortunately, he published in a French scientific journal, and so I think the translation took a while. And so Hubble, when later asked, he said that he had never heard of Lemaitre's theory before he came up with his own theory. He said he was totally independent, which maybe it was, maybe it wasn't. But anyways, Hubble was more popular at the time. But in hindsight, we can look back and see what George Lemaitre talked about. He also looked at the stars and their spectrum shifts, and he also hypothesized that the universe is expanding. But he took it a step further. He said that if the universe is expanding, then it must have been much smaller at an earlier time. So he tried to rewind in time and said, well, if the universe is getting bigger, then that means now is bigger than it used to be. It used to be really small. And so he actually called this the cosmic egg. He said that the entire cosmos, the entire universe, used to be one little egg, and it has expanded from there. And his opponents, or the opponents of this theory, called it the Big Bang because they thought it was a ridiculous sounding name, which it is, and that is what has stuck. It's actually not a bang. There's no explosion. It's just the idea that the universe used to be really small, and it has grown. It has expanded since then. Einstein, who has come up here and there, the most famous scientist ever, he refused to accept it. Einstein insisted that the entire universe had to be never changing, always the same. And so Einstein looked at all his work and he said, your calculations are correct, but your physics is atrocious. Basically, he disagreed with the interpretation of all of the calculations and the equations. But unfortunately for Einstein, Lemaitre and Hubble have been proven correct. The universe is indeed expanding, and it is changing with time. It is not constant, as Einstein himself saw. Lemaitre, I really encourage you to look into him. He is an interesting character, and he could probably really relate to us at ENC. He graduated from a Catholic college, and as an alumni, he later went back and taught there. He was a professor there. So he was at a small Christian college, but he really opposed mixing science and religion, right? So there are all these different ways that we've discussed about how science and religion should be in conversation, or whether they're in competition, at war with each other. Lemaitre's point of view was that they're totally separate, and his beliefs of religion should not affect his beliefs of science. Science is just looking objectively at the data, whereas religion is his beliefs through the Bible and his philosophy and theology and faith. Right, so he's a really interesting character. I encourage you to look into his story more. So today, most astronomers believe the Big Bang Theory, that the universe began as a extremely small, extremely hot, extremely dense entity that rapidly expanded 13.8 billion years ago. That number used to be somewhere between 13.4, 13.7-ish, somewhere around there. Astronomers are more or less coalescing on the idea of 13.8 billion years ago is when it started to expand. And so with our present knowledge of particle physics and of our understanding of the universe and of the fundamental forces, we can extrapolate and go back in time to maybe about 10 to the minus 43 seconds after the Big Bang. Right? So that means for the first 10 to the minus 43 seconds, we actually have no idea what happened. We're guessing. There are a lot of ideas out there. But ever since that point, based on our current understanding of physics, we can explain what happened since that moment. And so on the canvas, I've posted a few links for a video explaining what the Big Bang Theory actually is, about what happened since that 10 to the minus 43 seconds after the Big Bang. Then also a couple of other videos outlining the evidence for the Big Bang, why it is so commonly accepted today. And then also about at least some of the problems, especially one of the big problems with the horizon problem and how that's been resolved. And so after you've watched those videos, come back and I'll have a conclusion video that'll talk about some of the kind of unsolved mysteries of the Big Bang Theory that's left, and a few more of my thoughts to pull everything together.